Alright, so recap for the video. We want to solve for x, but x is trapped underneath the radical. So the opposite of square rooting is squaring. So we square both sides to get rid of it. We're left with what's just underneath, so x minus 3. 5 squared is 25. Solve for x to get 28. Again, what did we just talk about was super important for us to do? Check. You have to check. Check for those extraneous solutions. Okay? And again, to check, all you have to do is just plug your answer in. You take 28, plug it in. Simplify it down. Well, what's 28 minus 3? 5. And what's the square root of 25? So does 5 equal 5? Yes. So 28 works. You got the same thing on both sides after you plugged it in. So 28 is good. That's not an extraneous solution. That one's okay. But you just have to check for them because sometimes you will have it. Right? You just have to make sure. If we look at B, before we can start getting rid of your radical, it has to be isolated. It has to be all by itself. So if we look here, this radical could be the only thing on that side of the equal sign. Anything outside of the radical needs to be moved over to the other side. Okay? So we have that 3 on the outside. How do you think we need to move that 3 over? We're going to do? Yeah, very good. We're going to divide by 3 because we're multiplying the 3 in the radical. So to get rid of it, we just do the opposite. That way they cancel out. And we're just left with the square root of x over 2. And 15 divided by 3 is 5. Okay. So again, if there's stuff being added or subtracted or multiplied on the outside, move it over. That way you get the radical by itself. Now that we have that radical by itself, how are we going to get rid of it? Square. Yeah, square both sides. Do the opposite. Gets rid of the radical, and we're just left with what? X over 2 is equal to, what's 5 squared again? 25. Now we're just back to that basic equation to solve. How are we going to solve for x? Times 2 on both sides. 1 by 2 times by 2. That way they cancel. And 25 times 2 is 50. So x is equal to 50. What do we have to do with 50? Plug it in. We have to check. Super important. Not an option. Part of the problem. Okay. And in the check, you just plug it back in. Take 50, plug it into the original. Make sure it works for the equation. Well, what's 50 divided by 2? 25. And the square root of 25 is 5. And 5 times 3 is what? 15. Okay. That works. If you get something goofy like 7 equals 15 after you plug it in, well, 7 doesn't equal 15. So that's kind of an indicator to you that it's an extraneous solution because it's not kind of equaling out. So we got the same thing. That's good. Questions over there? So you look at C. And we want to isolate this radical. So anything not in that yellow box, anything not inside that radical, needs to move over to the other side. Okay? let's just say we had something like 2x plus 7 equals 13. Let's say we were solving a normal equation like that. We want to solve for x. Which one would we move over first? The 2 or the 17? Sorry, the 2 or the 7? 7. You're going to isolate your radical that same exact way. Okay? So which one are we going to move over first? The 2 or the 7? The 7. Okay? So whatever you're adding or subtracting on the outside, you want to move that over first. Okay? Just like a normal equation. And 13 minus 7 is 6. Now, what do we need to do with that 2? Divide. And 6 divided by 2 is 3. Okay. Again, whatever you're adding or subtracting on the outside of your radical, move over first, then divide the number. And there's a number out front. Just like the same order you would do in solving like a normal equation. So now, we got the radical isolated. How are we going to get rid of it? Square both sides. That gets rid of the radical, and we're just left with what's underneath. And 3 squared is what? Well, the x by itself, what do we have to do with that 5? Subtract. So x is equal to what? Are we going to move on to the next one? Oh, what did you? Check. Don't forget to check. Big thing. Simple thing, you just have to plug it in and plug in your calculator. We have 2 radical 4 plus 5 plus 7 equals 13. Well, what's 4 plus 5? 9. Well, what's the square root of 9? 3. And 2 times 3 plus 7 is what? 6 plus 7 is? 13. When you plug that in, you get 13 equals 13, so we're good. Questions on that?
If I like plugged in 2 radical 9, and then I got 6, and then on the other side I had, like if I had 6.
If you just show, you plug it in, you show like 1 or 2 steps, show that you get the same number, that's fine. I just need to see that you checked it. Okay? Just be careful of plugging it in, make sure you plug it in right, because if you mess up plugging it in, you'll think it's extraneous and then you'll get the wrong answer. Be careful. But yeah, that's fine. Okay. Questions? No questions? Okay. Last one. Maybe it's time to practice. So with this last one, is the radical already isolated for us? Yeah. Already by itself. We don't have to move anything over. Everything that's on the same sides underneath it. So again, how are we going to get rid of that radical? Square. Square both sides to get rid of it. So here we're left with 2x minus 3. So you got rid of the radical. What do we have to do with that other side? Because you're not just squaring the x, and you're not just squaring the 3, you're squaring x minus 3 altogether. And it might be super tempting, talked about this before, to do this. Don't write this down, but it's super tempting. Just say x squared minus 9. Right? It's not really something to do, but we can. Okay? Then remember what we have to do? What are we going to do? Yeah, very good. Sorry, I couldn't hear you. Now, we need to write it twice because we're squaring it. So that's the same as saying x minus 3 times x minus 3. Then what we have to do? FOIL. whenever you have something like this, don't distribute that exponent. Don't do it. You write it twice and then you FOIL. This guy right here is just going to stay 2x minus 3 for right now. So when we FOIL, x times x is x squared. X times negative 3 is 3x. Negative 3 times x is just negative 3x. And negative 3 times negative 3 is positive 9. Combine your like terms. Pull your way to negative 3x minus 3x. Negative. Yep. Plus 9. Okay? Both times we FOIL. We have an x squared there. So what do you think? What method are we going to use to solve this guy when we have an x squared? Everyone's favorite thing to do. And what are we going to do? We're going to factor. Whenever we have an x squared in a problem, it should be triggered in your mind. I'm probably going to end up factoring this. And when we factor, do we want a negative x squared? No. I mean, you can, but it just makes more work for yourself. So I'm going to keep the x squared out and all this stuff already on that side. I'm going to move the 2x over, and I'm going to move the negative 3 over to keep my x squared positive. Okay, so how are we going to move the 2x over? Subtract 2x. And again, when you move it over, combine them up with their like term. Cancels. How are you going to move the 3 over? Add it. And again, match it up with its like term. So 3 is going to match up with a 9. We didn't combine anything with the x squared. When we combine negative 6x and negative 2, what does that give us? Negative 8x. And then 9 plus 3 is. So now we're going to factor. We have 3 terms. What method of factoring do we use? Split the method. So technically, we have a 1 on the out in front. Multiply your first and last. 1 times 12 is 12. Shortcut's just the back number. 1 is 1 out in front. Now let's solve the factors of 12. 6 and 2, what else? 1 and 12. 6 good and 3 4. Which of those are going to combine to give you your middle number? I'm going to say 5. Good. They're both going to be negative because they're adding to give us a negative 8. So use those values to rewrite your middle. And then group. So what can we take out between x squared and 2x? Just an x. And what are our leftovers? 2. Drop down that negative sign. And then what are we going to take out between 6 and 12? 6. And good, Stan, you're right, that's a negative 6, so what are our leftovers going to end up being? X minus 2, because that GCF is technically negative, so that means that middle sign is going to change to the opposite. We want from being plus to a minus. If you flip-flop them, yes. Yeah. So if you switch the order and you did x squared, if you did like x squared minus 6x minus 2, yeah. Your GCF will be x and negative 2, and then you'll get x minus 6 on the inside. You'll end up getting the same answer. So it doesn't matter. Right, your parentheses. What's going to go in each parenthesis?
X minus 6.
X minus 6, and the other one's going to be? X minus 2. So you flip-flop them, you'll get the same parentheses. That doesn't really matter. And then solve. So we get x is equal to 6 and x is equal to 2. Well, are we done? No. What do we still have to do? Check. You can't. I know you just did so much work. You can't forget to do it. You have to still check. And how many answers did we get? 2. So how many checks do you think we have to do? 2. Okay, you have to check both of them. So just take 6, plug it back into the original. Is equal to 6 minus 3. Well, underneath that radical, what's 2 times 6 minus 3? About the square root.
Oh.
And 6 minus 3 is 3. Now what's the square root of 9? 3. So we're good there. X equals 6. So we're good. I'm gonna write that. Well, let's check 2. You have 2 answers. But sometimes both can be right, both can be wrong, one can be wrong. All depends. So go ahead and take 2, plug it in. So underneath the radical, 2 times 2 minus 3 is what? 1. And 2 minus 3 is negative 1. Ooh, the square root of 1 is? Does 1 equal negative 1? In a way. What is that? Is that? Yeah, because that plus or minus kind of what we talked about, but in this scenario, ignore that. That's when we're solving quadratics, where you get a plus or minus. Like when you complete the square. When it's just this, don't worry about the plus or minus rule. We're going to pretend that doesn't exist. So yeah, I mean technically you think about it. Technically. So, you got 1 does not equal negative 1. So does that mean x can equal 2? No, so you have to state that. Okay? That's why it's important to check. You have to check for those extraneous solutions, the ones that don't work when you plug them back in. Okay? Question.